So all the things that I wanted to put together in terms of demonstrations have not come together fully, but I will still be talking about different aspects of pen testing, Azure, and some of the useful information that we need to know. So quick information. So I think my screen sharing got dropped out because somebody else started sharing their screen.
Oh, sorry.
No problems at all. Let me do that again. So can you see my screen? Can you see my screen now again?
Yes, we can. I can
Okay,
see.
yeah.
It's good.
Nice. Okay. So
yes, it's visible now.
Nice, excellent. So quick information about me. As Paul said, my name is David Okeyode. So my role is I work as a cloud security architect, and what it means is I work with customers and organizations around the world in securing their public cloud platforms. So that includes Azure, that includes AWS, that includes Google Cloud. Increasingly, it's including other clouds like Alibaba Cloud and IBM Cloud and on and on. But it's those three main platforms that I focus on. So Azure, AWS, Google Cloud. So like Paul and yourselves, right? I know you're very much involved in the Azure community, and that's why you're on this call today. So I'm also very much involved in the Azure community, even though not as much as I would like to. I have a blog that I run called azurehangout.com. I'm very much interested in learning about Azure all the time. So I've done almost all Azure certifications apart from the data certifications. So I recently just did the Azure IoT developer certification and on and on. So I'm very much involved in that sense. So quick information about what I'll be sharing with you today. So the title is called Azure Pen Testing, but it's going to cover a little bit broadly around Azure security because it's important, because the goal of pen testing in the approach that we're taking is to help us to understand how security works in Azure and some of the things that we could be doing to protect ourselves when we're talking about the Azure platform. I'm not sure how much familiar we have with security in Azure, but there is this amazing document called Azure Shared Responsibility. So it is a nice document by Microsoft, right? It goes into details about how security works in Azure and essentially highlighting what our responsibilities are when it comes to securing the Azure platform. Azure is a public cloud platform. And what that means is that we're not responsible for everything. But one of the mistakes that I've seen many people make when they start talking about security and Azure is many people assume that they have no security responsibility when they're talking about the Azure platform. Many people just assume that everything is all up to Microsoft. But as you can see on the diagram that I'm sharing with you on the screen now, let me see if I can make that a bit bigger. Yeah, so I think that's better. As you can see on this diagram, we have all these different layers of security, right? Security always has this principle of this defense in depth. And defense in depth principle means that there is no silver bullets to security. You can't go, I've implemented a single solution and that's covered all my security. Security has to be holistic. You have to look at things from multiple angles. You have to look at things from multiple perspectives, and you have to have multiple layers of defenses to protect yourself against different kinds of threats. Also, the threats that we're protecting ourselves against, they are continually evolving. So our security also must continually evolve. So what this chart is showing is the blue indicates the customer's responsibility when it comes to security, that is us. The gray indicates Microsoft's responsibility when it comes to security. Azure has different types of services, as infrastructure as a service type services, platform as a service, and security as a service. Regardless of which cloud service type you're using, you're never without security responsibility. Even if you're using software as a service, 100% of security of your information and data, of your accounts and identity, and of your devices is your responsibility as far as Microsoft is concerned. Remember, this is an official Microsoft document. So one of the mistakes that I've seen people make is just assume I have no responsibility when it comes to all of this. All of that is all on Microsoft. Well, that's not the case. We have responsibilities, and it'll be very useful for us to learn what those are and make sure that we have something in to protect us. So moving on very quickly. So when we talk about things like penetration testing, and essentially in the context of the cloud, it's like, are we just talking about hacking Microsoft Azure and hacking the Azure cloud? Well, a little bit of that is true. Pen testing and hacking are sort of like similar, but there is a major difference. The major difference between hacking or just pen testing has to do with permission and reporting. So when we're talking about people doing pen testing, what that means is that you have explicit permission from the account owner or from the information or digital asset owner, permitting you to try to exploit their environment. And that is very key when we talk about something like Azure, because Azure pen testing has to start with understanding the rules of engagement. That's very important. Before I show you what those rules of engagement are, let me share very quickly what the consequences of not following the rules of engagement could be. So for example, if people take some of the things that we're talking about or some other information that you find with your own further studies and you use it indiscriminately, that could lead to your account being terminated by Microsoft. And that's the least of the worries that you have, right? Microsoft terminating your Azure account. It could lead to Microsoft bringing legal action against us if we do things against or contrary to the rules of engagement, or even worse, it could lead to financial liability, where Microsoft are going to require us to pay for damage to the Microsoft cloud and even for damage to customer data. So it's very critical that before we do anything with pen testing in Azure, we understand the rules of engagement and we do our utmost best to adhere to that. Always err on the side of caution. So what are the rules of engagement? Let's bring up Microsoft documents. So all these links that I'm sharing with you, I'll share them with Paul, and Paul can send them around so you can have a read through them. So the Azure penetration testing rules of engagement, I'll just call out a few information. I won't go through everything. So I'll just call out a few things. So the main thing that we need to understand is that depending on which type of service that we're talking about, we have limitations. So for example, at no point in time are we allowed to try to access other Azure customers' information or data. At no point in time are we permitted to do any kind of denial of service attack. So you're doing DDoS attack against the Azure platform, you're not allowed to do that. Even if it's against resources that you think belongs to you, right? Maybe like Azure storage. Remember that the underlying infrastructure behind those resources are shared with multiple customers. So at no point are we allowed to perform any kind of denial of service attack. At no point are we allowed to perform anything that generates a significant amount of traffic. Again, that could lead to denial of service attack. At no point, again, are we allowed to access any type of customer data or trying to do phishing against Microsoft employees. That's not allowed. So the thing that's encouraged, you can see that it has a very limited scope. So what's encouraged is, so you're creating test accounts to be able to demonstrate or prove different types of security solutions. You are allowed to do pen testing against Azure virtual machines, because virtual machines in that context from the operating system layer above that belongs to us. So we can do pen testing against that. We can do port scanning. We can run vulnerability assessment, which I'll be doing some of those today. And we can do fuzzing. So load testing and all that stuff against virtual machines, again, that's allowed. So essentially, that's sort of like the limit of what we're allowed to do. So please keep that in mind whenever we start talking about what we're doing. So that being said, let's have a quick review at this Azure attack matrix. So when we talk about pen testing, there are multiple types of attacks. There are multiple approaches to take. But if you look at everything from a philosophical perspective, they all come together in sort of like a specific method. So initially, whenever you're looking at doing pen testing, you usually start with some scanning or some recon. What that means is that you're trying to understand the targets that are available out there. What targets do I have that are available on the Azure platform that I'm pen testing against? So that's where we usually start. So let's start from number one over there, scanning and recon. And in terms of what targets or understanding what targets are available. So number one, let's go scanning and recon. What are the targets? And when it comes to this case, we actually get a lot of help from Microsoft in understanding the targets that we can attack in this case. So, for example, let me bring up some other documents. And by the way, I've got a machine over here that I'll be using for some of the stuff that I'll be showing you. So let's go to this document. So let's go to, apologies. So we're talking about understanding what the targets here. So here's a document. And what this document is, it's a published list of Azure IP address ranges. So if you download this document, you get the link to this document. It's going to give us, let's open that in Visual Studio Code. Let's bring that up here. So that's going to give us information about different IP addresses of Azure for particular regions, for different regions. So essentially, we have a list of targets right in this list. But of course, in some cases, we may want to be a bit more specific. Remember that what I'm talking about is not something that you're allowed to do. This is just for educational purpose. So we're not allowed to go scanning against every single IP address in Azure. But what I'll do is I'll go to my machine over here. So my Kali Linux machine over here, and I'll just download the list, and I'll show you how how even bad actors could begin to filter this list to identify targets that they could attack. So let's download that list, and let's go get the updated link. So let's go copy that link address, and let's go to that. So now we have this list on this local machine. So that's the list over there. So we can begin to filter it. So let's say I wanted to focus on virtual machines in the UK South region. So I could use a query like this. So I could use a query like this. And I could put that, get my file. And what that is saying is that what I'm doing there is I'm saying, go through this document. I want you to get any aspect of the document that the region is UK South, and if it's the Azure platform. So Azure has three main clouds. You have the Azure public regions. You have the Azure geofenced region, that is Azure Germany and Azure China. And we have Azure government, which is essentially Azure US government. So in this case, I'm specifying not Azure government or Azure Germany or Azure China, I'm specifying Azure public regions. So if I want to pass through those lists, let's do a quick installation of apt install JQ. So JQ is a tool that helps us to format JSON documents. So that's what I'm installing. So it's a nice tool to be able to format and query JSON documents. So let me go JQ. So that's installed now. So let's clear the screen and let's run my command again. So, and there you go. So what I have here is I have a list of all the IP addresses or the Azure IP addresses for UK South region. And then I can begin to be more specific. Let's say I want to focus on virtual machines in Azure UK South. In this case, what I can do is I can start filtering for just that. So let's go to that. And what I'll do there is I'll need to go grab my file name. So let's grab this file name. All right. And I'll need to specify that in with the arrow. And what I have here is I have just IP address ranges for virtual machines in UK South. So now that an attacker has a list of IP addresses in UK South, the next thing that they do, which is still part of phase one of scanning and recon, is what are the targets? It's what parts are they listening on? what services are they running? So it's not just ports that you're listening on. It's like what services are they running? What's the operation? I want to know as much as possible about the targets that I'm going against. Again, so apologies for sounding like a broken record. Remember that what I'm talking about is not something that we're allowed to do. In the context of what we're allowed to do, if a customer were to say to you or were to say to me, David, I want you to pen test my Azure environment, what I will say to them is, can you run a script and get me a list of all your public IP addresses? And then that will be my starting point, right? So I'm just not allowed to go indiscriminately scanning everything. So in this case, I know what the targets are. I have the IP addresses. Now I want to start checking them out. So in this case, when we're talking about tools that we could use on Kali Linux, we're talking about tools like Nmap. We're talking about tools like Nessus. We're talking about tools like Nikto and many other tools, the SmartScan also. And these tools have different use cases. So for example, Nmap is a very good tool for being able to scan networks and being able to scan IP addresses, check out what services are running, what port is open, and on and on. While Nikto is good for web servers. So it's a web server scanning tool. And then you have like MassScan that's very good for massive amount of IP address ranges within a very limited amount of time, and on and on. So in this case, if I go back to my machine, I'll just show you some of those simple use cases. So let's clear the screen. And let me go ahead and introduce some other thing in this case, because in order not to break the Azure framework, what I've done for this demo is I've got a virtual network in Azure with a public subnet. And within this virtual network and public subnet, I have a virtual machine that's running in there. And that is what my focus would be on. I'm not going to go beyond that. So let's go get our icon for our... So there we go. So that's my virtual machine. My virtual machine has a public IP address, and that's what I'm going to start trying to understand these targets, right? What exactly is running and what it's listening to. So public IP. So let's go do that very quickly. Let's go to my Nmap scan. So what I'll do is I'll just do Nmap. And I'll talk about what this means in a minute. So the IP address of what I want to scan, which is a machine that's currently being hosted on the Azure platform, is, let's go grab that IP. Let's go under virtual machines. And I will be grabbing, so that's the instance that I'm scanning against. So if I start running that, so while it's running that, I'll talk to what some of these are doing. So the V means I want to run this in verbose mode. In other words, I want you to play out all the information for me. So when I'm talking about this -A, I'm saying show me the routes and the hops between myself and this target. When I specify the -SV, so what I'm saying is I want you to try to detect. So let's go to the -SV. What I'm saying is I want to try to detect the services that are running on the different ports that are opened, and also the versions of the services, because that's where an attacker starts from. I understand the target, I understand the services that the target is running. Then the next step is, what is that service vulnerable to? What are the different exploits that I could take advantage of? So that would be the next step. So in this case, what is this result giving me? So this result is saying to me that this IP address is listening on those ports, port 80 and port 22, which is standard, just a standard port. So it's listening on those two ports. The other thing that this is showing me, if I keep scrolling down, it's showing me the service that's listening on port 22. So it's telling me that I have OpenSSH version 7.2 running. So that is good information, because then I can now try to figure out what that version of OpenSSH is vulnerable to, right? It's telling me that port 80 is running Apache, and it tells me the version of Apache that's running. And again, I can start looking into that. The other good information that I'm getting from here is that it's showing me that this instance as a WordPress directory, which is sort of like an indicator that this is running a WordPress website, which is exactly what this is running, right? And then you start going down, it tells me the HTTP methods that I support, the get, the head, and the post HTTP method, which means I could do uploads. And if that's allowed, maybe that's behind some form of authentication. We'll need to find that out. But I could do get, head, and post. And it's also giving me guesses of the operating system version that this is running. So once I have this information, that's good. That's identifying the targets, right? So let's go on very quickly because I'm looking at the time also. We need to be a bit careful. So the next thing that we're going to do is what are the vulnerabilities of the targets? And for this, we have tools like OpenVerse. So let's grab these over here. So for vulnerabilities, we have tools like OpenVerse. We have tools like WP Scan. We have other tools, Qualys and some others that could just scan through the ports that are open and also help to identify what vulnerabilities could exist on those. So in this case, having understood that this has a WordPress website, I want to see what that's vulnerable to. Bless you. So let's go. So I've got WordPress scanner on this machine, on this Linux instance, which is WP Scan. So I'm going to be using that to identify what this target is vulnerable to. So let's go grab that very quickly. And you can see that I've also got, as part of the initial scan, I've got the name of the site. So very useful information. So let's grab our scan. So in this case, what I'm going to be doing is I'm going to be doing some enumerations with WP Scan. And I'll explain what I'm doing in a minute. So I want you to do a quick scan of that. And I want you to just enumerate user information that you could find on this target. So let's run that to begin with. So that's scanning the IP address, and it's giving me some useful information here, right? So what I asked it to identify for me a user, so it's identified as a user account called Azure Admin that exists on this machine. So I found that out so by using an aggressive type detection. So that's very useful information. But beyond that, what I want to find out is what are we vulnerable to? Well, what's the target vulnerable to? So what I'm going to do is I'm going to modify this from enumerate users to enumerate vulnerable plugins. So by the way, before I do that very quickly, let's just do a WP scan -h. And you can see the different options that are available. So the ones that I'm using is I'm using the enumerate option, and you can see I can enumerate user ID ranges. But these are very important ones because what this allows me to do is to enumerate vulnerable plugins and vulnerable themes that this site could be vulnerable to. So that's what I want to do next. So let's do show me vulnerable plugins that the site is vulnerable to. And if I run that, goes through the process, and this is very good because what this has now listed out to me, right? I won't go through everything in details, but what is this listing out to me is to say, hey, this site is running this version of this plugin or this version of this application, and here are the vulnerabilities that are known for that particular version. That vulnerability was fixed in this version, but somebody has not done the update. So, and it's also giving me links and references that I can use to go find some information on about that vulnerability. So I won't go through everything because of time. The main one that I wanted to exploit in this case would be, if I scroll down here, there is a plugin that's installed on this WordPress instance that allows for an unauthenticated remote code execution. Now that is bad. That's not good. Unauthenticated remote code execution means from my attacker instance, I could execute certain code on this instance without having to even authenticate myself, right? That is like really up there with bad vulnerabilities, right? So that's not good. But it also gives me the link as to if I want to understand how that can be exploited. So for example, it gives me those 2 links. So let's go grab those 2 links. And if my corporate IP addresses allows those, I can show that to you. So let's go over here very quickly. And it's giving me information about how to exploit this. For example, this is not like fully clear, but what this is saying is this particular vulnerability means I can create sort of like a payload file that's publicly available. I can pass certain commands that I want this to be able to execute. I can pass certain commands to it, right? And then I can call the victim website and then pass the payloads to it, and it's going to execute the command on the instance. So that's what this is showing me. So what I'm doing in this case is I'm going to be using Azure against Azure. So let's go back to this diagram. What I'm going to be doing in this case is I've got an Azure storage account that's hosted here. I've got the payload hosted within this Azure storage account. So that's the payload there. And I'm going to be referencing that in the weaponization against this instance. So that's going to be referencing that payload over there. And it's going to execute whatever commands that I have in that payload. So let's go to the initial one. So in my Azure environment, if I go under my storage account, I've got this storage account where I've got 2 payloads there. So if I go under the blob service, under the container, if I go under exploit, I've got this payload, which is just a simple one. Let's grab the URL of this payload. So the URL, so you can see that it's relatively straightforward. All I'm doing is I'm executing a single command to say, show me etc password, right? So, but that's just the beginning. So let's see if that's if I'm gonna be able to exploit that against this instance. So what I'll be doing is I'll go to, actually, let's use the browser against that. So I'm going to use the browser and I'm going to call my payload against that vulnerable instance. So if I go ahead and I run that, so yeah, and that seems to have worked. So what this is doing is that I'm getting the machine to dump out the content of its different directory out to me. Now, here's where it gets interesting when we're talking about pen testing in the context of Azure. One of the things that's popular for pen testing is the local metadata service, which is the local metadata service that exists on Azure virtual machines. So there's a local metadata service that could give me detailed information about this machine and the environment that it's running on. So I'll put a link to Microsoft Documents on that local metadata service. So let's go over here. Let's go to that. And Azure Instance Metadata Service, what that means is that you could execute certain commands on the machine and you can get information about, and essentially information about the machine and the environment that the machine is running in. So that's very useful stuff. So what I'll do is, how about if I can verify using local metadata service, I'm going to trick this machine instance to spit out to me an access token that I can use to access the rest of the Azure environment. You say, how do you do that? 1 minute. Let's go back to my diagram and let's introduce some other concepts. So there is a particular capability of Azure called managed identity. So managed identity in Azure, similar to what AWS called IAM roles, allows us to be able to assign permissions to instances in Azure. Right? So we assign permissions to instances, or we assign a managed identity to the instance, and then we can give this managed identity certain key permissions to the Azure environment. And what that means is that if we can steal this token that associated with this managed identity of the instance that we're exploiting, whatever this machine has the permissions to do, we can do that within this customer's or within this victim's Azure environment. So which is essentially what I'm going to try to do with the second payload. So let's go very quickly to that. If I go over to payload text number 2, and if I go to that link, let's go have a look at what that payload looks like. So what I'm doing here is I'm saying I'm tricking the instance to run a command that will go grab its managed identity token, and it's going to spew that out to me. And then once I have the token, then I can go ahead and reuse that. So let's see if this machine is going to be tricked to spill out this token. So what I'll do is I'll go grab the same thing, but this time around I'll reference payload 2. So that's payload number 2, which is going to trick it to run that instance. And let's run that again. And without the dash in the beginning. And this is interesting because now we have an access token that this machine just spewed out to us. And this access token has certain permissions that, oh, no. So I said the question is managed identity similar to Active Directory. Managed identity is an object in Azure Active Directory. So I will show that to you in a minute. So let me just put this token very quickly in this. So, and let's make this a bit, let's go to toggle word wrap. So I have an access token, and I can see the expiry time of this access token. And ladies and gentlemen, with this access token, I can begin to do other things within this Azure environment. So I won't show you, I won't go through the next rest of the steps because of time also. But what we could begin to do once we have that access token, we could get information about the subscription that this instance is running in. We could get information about the Azure AD tenant of this Azure environment. And once we have those two pieces of information with the access token, I can begin to do other things like begin to look on the app services that may be running in this environment, for example. And I can begin to look into app services, and I can see if there are certain parameters that are exposing things like storage accounts, connection strings, SQL database connection strings. So I can begin to just poke around. So I can begin to expand within this environment. Maybe I'm going to be able to steal another credential from an Azure app service or Azure function that's running somewhere. And then I can take the other any other credentials that I'm able to steal. I can generate a token based on that, and then I can begin to use that to explore the environment. And the goal will be to steal as many credential tokens as I could to be able to see how far I can get within this victim's environment to be able to start accessing important stuff like Azure SQL or Azure storage account where data or information could be stored. So without going into too much detail, that's sort of like a quick overview of how something like that could work. Now you may be thinking, yeah, David, you're showing me this. Is this something that's practical? Absolutely. So without mentioning names, there was a major bank in the United States that had a breach sometimes last year in the public cloud, not in the Azure cloud, but in the public cloud. But the attack that happened with that organization happened in a similar fashion to what I just described to you. So an alleged attacker was able to compromise an instance, found out the vulnerabilities of that instance, and then generated a token from the row that's associated with that instance. And then they found out that the token that they stole, that they were able to generate, has permission to be able to read all the storage account. And then they started downloading all the content of all the storage accounts in the environment. So this is not something that's in particular, it's something that happens all the time. In fact, it's happening to many people that they have no idea about. So what sort of like the defense against something like this type of attack? Number one, number one, patch things up. It's important. We can't say that enough. Keep things up to date. Patch your stuff, especially if they have public IP addresses. You have instances running in Azure that have a public IP address. What that means is that you're exposed to more risk. Keep them patched as much as possible, whatever the disadvantage, whatever the discomfort is, because all it takes is for a simple vulnerability to be detected that allows something like remote code execution for this type of attack to be successful. Number two, practice something like defense in depth. And what that means is you have layers of security where you have maybe a web application firewall in front, not just exposing public IP addresses directly. Maybe you have some kind of network antivirus system that's scanning whatever traffic that's coming in, right? And being able to go through that security tier before getting to your backend instances. So also have those multiple layers of threat defense within your Azure environment. So I'll be quiet there. I think that's where I'll stop. I've got some questions in the chat window. So let's see if we can take some of the questions and then we'll go from there. So what questions do we have? So Shola asks the question, is managed identity similar to Active Directory? Can the target machine give out passes and authentication under Azure AD? Can Azure AD be hacked? So that's a lot of questions. So I'll try to take that one at a time. So managed identity, if I go to, and I'll have links to some documents that you could go through. So managed identity is a way to assign an identity to a service, right? So we assign identity to users. We create a user account. In Azure, we have something called service principles. So service principle is what people typically used in the past. What's traditionally being used is service principle. But service principle has its own set of issues. Well, some of the issue with service principle is how do you secure your key and your ID, right? That's a big thing because if someone gets a hold of the key and the ID, essentially they have the identity. So managed identity is meant to be a much more secure way of provisioning service principles for Azure resources. So in the case of this virtual machine that we're exploiting, if you go under identity, you assign an identity to that instance. So this virtual machine has an identity associated with it. So that was switched on. And what that does is it creates a managed service principal in Azure AD. That means that we don't have to touch the key. We don't have to touch the ID, the access ID. We don't have to touch the key, which is good, which is a step ahead of service principle. But we can also still do the same thing. So for example, in this instance, this managed identity actually has permissions to this subscription. And now the token that I just stole, whatever permission that managed identity, which is this one, whatever that managed identity has, which is that, it's got reader permission. Now I can start reading the environment. So that's the first. Hopefully that helps in your understanding of managed identity, Shola. So the second question is, can the target machine give out passes and authentication under Azure AD? Yes. So which is essentially what we did, because all the way that managed identity works is you make an API call, a local API call to this metadata service. And this metadata service will go grab you a token in Azure AD. So that's how it works. So this machine can obtain passes. So it cannot give out passes, but it can obtain passes. But what we've now done is we get this machine to obtain a pass for us, and then we steal that pass. So that's what we did. So it cannot give out passes, but it can obtain passes based on the identity that we've assigned to it. So hopefully that makes sense. The third question, can Azure AD be hacked? Anything can be hacked. At the end of the day, we're talking about software here, right? So when you talk about software has the thing with software is it's written by humans, right? And humans make mistakes. And when mistakes happen, you have vulnerabilities. Somebody else has looked at your code and your application and figured out a way to exploit it. So Azure AD is a very secure service that Microsoft put a lot of money into maintaining its security. But that does not mean that it cannot be hacked, right? So there's nothing that cannot be hacked. So what all that means is maybe no one has figured out a vulnerability yet externally, but it doesn't mean that it doesn't have vulnerabilities. So so for example, one of the services in Azure that is a very secure service, still a very secure service, is Azure App Service. But there was like a report that came from Checkpoint late last year, where they were able to escape from an Azure App Service. So that vulnerability has been patched now. But essentially, you can imagine like customer A's web app is running on this app service. Customer B's web app is running on this one also. So what they were able to do was they were able to escape out of their web app environment, and that allows them to be able to explore other customers' app environment. So obviously they reported that to Microsoft once they saw that, and Microsoft has now patched that. But again, Azure App Service had that vulnerability last year that's now been patched. So any other questions? If there are no other questions, Paul, I think I will just hand back over to you. Are you there, Paul?
Yeah.
Yeah,
yes,
sorry.
I am. Yeah. Thank you very much, Mr. David Oyedeji for, I guess I get the name correctly. Yeah.
Close.
Thank you very much for this wonderful section. I believe everyone learned from this class, even though I missed a lot from this, having some little issues here, but it's been fixed. I want to say thank you, Mr. Okeyode, for your time being with us on this call. Please, if you have any questions regarding security on Azure, you can possibly put it on the chat group and our chats, and I believe we'll have people to respond. Mr. David too is part of the community, the Nigerian Azure community, and if he has enough time seeing the questions, he also will answer some of these questions. I want to say thank you for everybody that joined the call, and from us from the Azure community, Nigerian Azure community. I want to say thank you to everyone. Yeah, tomorrow is another day. We'll be having another interesting topic tomorrow from Mr. Olumide. Mr. Olumide is a student of University of Lagos. He will be taking us into introduction of Microsoft Bot Framework. Last week, the Unilag team, they developed a bot application, and it's a very, very interesting application, and it deals with the COVID-19 issues we are currently facing. So one of the brain behind that application is Olumide, and Olumide is going to be taking us through the Microsoft bot framework, how you could use it to develop a lot of applications and answering of questions. So I want to say thank you to everyone being on this call, and see you all. And that is bye bye from me. Thank you, Mr. David, for your time.
No problems at all. Thanks very much, everyone.